Welcome to another episode of We Are Carbon. I'm Helen Fisher and I'm joined by Cade Frost of Source Bioplastics for a discussion about developing new plastic materials that could move the planet towards a healthier future. It may seem like plastics and healthy can't really go hand in hand, but as one of the world's largest industries, it's something that we can't pretend is going to go away. And with such vast and destructive impact on the planet, that actually makes it one of the biggest opportunities for improvements. Moving from synthetic to bioplastics gives the immediate benefit of reducing dependency on fossil fuels. But there is huge variation within these materials, and if we are to move forward at scale, there's much to be ironed out. Cade had spent years anguished by the issue of plastic pollution, and he recognised that it would take involvement from a full range of interests for real change to happen. He's made an incredible start by successfully developing a rapidly compostable plastic material made entirely from natural and non-toxic ingredients. I really appreciate the point of view that he brings with regards to understanding the needs of manufacturers, the current limits of disposal facilities, and the expansive potential when we consider moving things to a truly circular economy. I was thrilled that Cade allowed me to scrutinise him with my inquisitive questions around this topic. We discuss everything from the materials themselves to the impact on society and even considering whether it's possible for plastics to have a positive impact on the environment. You can keep up to date with everything from We Are Carbon by subscribing over on the website, wearecarbon.earth. Right, let's dive straight into the questions. I'd really be interested, Cade, if you could introduce to us the general differences between the plastics that we're used to and the materials that we're now referring to as bioplastics.
Absolutely, Helen, and thank you for having me. That's a great question. So the most significant difference between the most familiar plastics and bioplastics is that the former are usually synthetically manufactured with a base of petroleum, while the latter are plant-based. So plant-based plastics are likely to decompose a lot faster because they're organic and they decay faster than traditional plastic.
Fantastic. So it's really is it straight cut? Are we talking one material comes out of the soil, another material is essentially coming out of oils and petroleum and fossil fuels?
Well, the base of the polymers are so different types of synthetic plastics and regular polymers are fossil fuel based, but with plant-based plastics, you're usually talking about starches, you're talking about wheats, you're talking about these things that give the material a density.
Okay, so it sounds to me like we're talking, in my mind, two very different materials. You're saying something made from wheat, something made from starch, and then we've got these products that we are so familiar with that are hard, dense, they melt, they're malleable. In terms of the applications that they're suitable for, can bioplastics potentially replace all or most of our plastic needs?
Eventually, yes. Bioplastics are biopolymers, so they have the potential to replace most of our plastics, but we have some distance to go. Disposable plastics are our biggest concern because most of them are things that are thrown away after a single use. Companies engaged in this business have done a great job in tracing our most commonly used containers. Many products have been replaced, albeit at a really slow rate of adoption. We need more companies that make bioplastics and more companies that adopt them. But this is not just a one input, one output solution. Waste management solutions also play a big key role in how we move forward. What people don't realize is that many virgin plastics already have been mixed with bioplastics to reduce the time required for decomposition, which is really important and necessary step. So usually when people hear this, next question in most people's minds is, well, why not just use bioplastics and skip the rest, right? One reason for that is manufacturing adoption rate. However, the situation is about to change. C-level executives are paying more attention to sustainable development than ever before. This is unprecedented in the history of plastics. This is a big step forward, but unless there is sufficient supply to meet the needs of these manufacturers, there's no point in changing course if there's insufficient supply. Like anything, a reduction in supply pushes up prices. Understandably, without a reliable supply chain, it's too big of a risk. So the second reason is mainly due to durability. Virgin polymers made from fossil fuels such as petroleum and additives are superior to bioplastics in durability. The third explanation, there's a great deal that goes into plastic, bio or otherwise, than just base polymer. To make bioplastic genuinely compostable and biodegradable, one that can be tossed, let's say, like into a compost heap and not poison the well, so to speak, it must be non-toxic and harmless to the ecosystem. That also incorporates a non-toxic, eco-friendly, natural fire retardant, which isn't easy to come by. Polymers are flammable. There have been incredible discoveries and applications of such ingredients like tannic acid and polydopamine. But for all the positives, there's some negatives as well. For instance, polydopamine acts as an antimicrobial barrier, and this is a natural fire retardant, which is great for plastic films that are covering foods, for instance, and bioplastic that we want to last longer, but terrible for most other single-use containers. So these types of fire retardants most likely won't work well for most 3D print filament either, because since the future of additive large-scale manufacturing will likely depend on plastics with initiators, since they dry most instantly by UV rays. But natural flame retardant like polydopamine acts as a UV barrier. Does that imply that we'll likely need different grades of 3D filaments, some for smaller makers and companies not using large additive manufacturing, and others for companies that are? Likely that's going to be the case. It's exciting and it's challenging.
Yeah, it sounds very complicated in terms of the, the material properties, the chemicals. Are the additives you're referring to there, they're naturally based?
Well, at least for Source, they are, and that's one of our biggest goals because, especially with what's going on with virgin plastics now, and the fact that they're mixing bioplastics with them to decompose, that's still, for us at least, is a big red flag because obviously you can't just throw that into a compost pile and expect it all to break down naturally. So one of our challenges is making a bioplastic that's completely non-toxic, that is completely eco-friendly, and that has no additives whatsoever that can't be broken down and composted alongside, let's say tomatoes and lettuce. You know what I mean?
Yeah, that's exactly, in my mind, that sounds almost too good to be true, but is precisely what I would think is necessary for our future to be able to implement all of this packaging material, all of these plastics back into the soil. And what you're saying, I suppose, is that isn't across the board. That isn't, you can't just look at bioplastic and expect that to be the case.
That is correct. And I don't know, I can't speak for other companies. All I can speak for is Source, and our challenge and our goal is absolutely not having anything in the plastic that one doesn't biodegrade and two could cause any harm in any environment.
Yeah.
But correct, I don't think it's a guarantee across the board. No.
No, fantastic. And I think this is where this sort of discussion is very important because it's not always evident, even to myself. I've tried to find this kind of information and it's not crystal clear, it's not readily available. But if we look at back to the problem of plastics in their more conventional sense for a second, one of the huge benefits across the board is that plastics don't break down. That's the point. That's why we find them so usable. They're going to resist breakdown. But it's also that persistence that is the reason that they're such a pollutant, such a problem in terms of waste. So if we just sidestep from the bioplastics for a moment, what is the current situation with plastics disposal?
I'm going to get a little long-winded here if I haven't been already.
No problem.
So, based upon 52 peer-reviewed studies, almost everyone on Earth is consuming a credit card's weight in plastic every week through the air we breathe, the food we eat, and the water that we drink via microplastics. So, not only is it raining microplastics in dense cities, and it's legitimately raining plastic right now, but microplastics have been found in rainwater in the mountains of Utah, hundreds of miles away from any city. only 9% of recyclable waste materials are being recycled. Even when we send all these recyclables to the waste management facilities, only 9% of them are actually being recycled. The other 91% still end up being incinerated in landfills or in our waterways. Our recycling measures are failing when and if there are recycling measures in place, and where there are not, municipalities are burning plastics. And what they're doing with that is some of them are actually turning it on into their energy grids to power homes. But it's between them being able to transport those materials over to an incinerator, plus pump that energy out. It creates a lot of greenhouse gases. So that causes massive greenhouse gases. Further, 71% of deep sea ocean fish are found to have plastic inside of them. I mean, that's our food supply, that's our food chain. So we've been led to believe that it's a lack of education and proper disposal of plastics on the part of the public that creates these issues. And that is true to some extent. We need everyone to recycle. We can't stop recycling at this point, but that is only a small piece to a much larger problem solution pie. It is a band-aid to a system that's failing in most places, and though companies like OceanWorks are becoming extremely innovative in how they're collecting and reusing recycled plastic, we simply cannot keep up with it. We're finding amazing ways to degrade plastics in the ocean through different non-toxic chemicals, but it's still a long way off. And again, it's a band-aid to a much larger issue that we must change at the source. We must continue our recycling practices, but we also must dive deep into a long-term exit strategy away from all plastics that last longer than the products they're containing or preserving. There are very few things humans use that last 450 years. I don't know many things that anybody needs something to last 450 years. And though, historical sites are important, if we don't deal with these issues quickly and proactively, we won't be healthy enough to enjoy them. The main benefit of plastics is indeed their ability to resist breakdown, but we have overshot that breakdown marker by over 450 years. Further, some plastics could technically last forever. So let's talk about those plastics. Let's get specific about, let's say, everyday items many of us buy every week. Pineapple juice, for instance, with its high acidic content, has a max shelf life of 24 months. Almost all soda, no matter the brand or type, has a fizz shelf life of 9 months. I mean, sure, those things, the edible for human consumption items, are important to protect, but arguably aren't as important to protect to, let's say, chemicals. Since the adverse effects chemicals can have on all life, if they're not transported or contained correctly, could have devastating effects on the ecosystem. And everybody may not love bleach, but everybody knows bleach. Bleach begins to lose its potency after 6 months. It will work after the 6-month marker, but it rapidly begins to break down from there. Everything from silver nitrate to hydrofluoric acid to sulfuric acid has a shelf life of 24 months. Nitric acid, isopropyl alcohol, 36 months. Very few chemicals, though there are some like ammonia nitrate, that last 5 to 6 years. So what I'm getting at, my point is this. We're building and using fallout shelters for spring rain showers. We need to be formulating for what we're containing and protecting based on the shelf and use life, not for catch-alls. Will it make it more expensive? It doesn't really have to be. No one said we have to replace all plastics right away, but we must replace as much as possible. The argument is much like the one of self-driving cars. Self-driving cars aren't expected to never get into an accident, though some believe that's the case. They simply have to get into fewer accidents than human drivers, which they are. We're inhaling microplastics made out of petroleum. I mean, this is insane. It's not only creating huge consequences in our physical environments and sea life, but the health consequences it will create over 20, 30 years is unimaginable. If humanity all of a sudden decided it would eat and inhale petroleum for years on end, we'd be at a pandemic level DEFCON 5 when it comes to how we as humanity dealt and responded to the crisis. I mean, look at the big uproar over smoking and the initiatives that have transpired because of the cancers it causes. I mean, I'm a smoker, but at least I signed up. Stupidly, but I still sign up. And that's the thing. No one signed up to eat, drink, and inhale petroleum and other harmful chemicals, but it's happening anyway. So why aren't we responding in the same way? I mean, do we really always have to learn everything after there's so much loss, or can we get ahead of something for once and invest in better waste management infrastructure systems and solid R&D? And this is where some of the new infrastructure budget needs to be directed. I mean, we must change the ingredients because we are not changing consumption habits. They're only expected to grow as more people rightfully become more technologically advanced by having access to cell phones. Single-use consumption is going to skyrocket.
Yeah, this is the world that we live in. And I think there's a few things about what you've said there. I mean, firstly, the full 150 years, it's almost comical, isn't it? The extent of time. And I think more so because we live now in a more disposable world than ever. So much of the stuff that we use is actually expected to be 5-minute lifespan. So yeah, this highlights the need to, not just the need, but the readiness. We're already ready to turn our back on a lot of the durability factors, a lot of that long life. But something that you've mentioned extensively there is the sort of threat to human health. And I think this is important to review. The idea that we're swallowing microplastics, we're finding microplastics in our food. What is a microplastic? Is that where a plastic's failed to disperse?
So yes and no. So what happens within a plastic when plastic decomposes or it gets recycled or it gets incinerated, is that it ends up being exactly that, these tiny specks of microplastic. And they can be anywhere the size of, like, let's say, a pinhead to the size of a BB to even smaller and smaller. And the oceans are inundated with them. So the issue with them is that, I mean, you go out on the beach and you can see, where people have thrown out plastic containers, and this gets really annoying. Plastic bags, you see trash places. But the problem with microplastics is that some of them are so small that they're in the water droplets in our air. They're in the rain. So it's not hard to figure out that when we're putting these types of chemicals into our bodies without even knowing that we're doing it, by eating, I mean, a credit card's weight worth of plastic. That is per week. And nobody knows it's even happening. And so it's like, okay, and we don't really understand yet what that's going to do. I mean, we already understand what it's doing with climate change and what it's doing environmentally. I mean, we're it's plastics, it's carbon emissions, but we have no idea what that's going to do to us, in a 20 or 30-year time frame. It's a big deal. And these things, the problem is if we can't see them, with the naked eye, how can we possibly collect them, much less recycle them?
Yeah, it makes it feel as though seeing them in a big landfill would be, in fact, healthier and easier to deal with than we are making the problem invisible by incinerating, but we're making the problem considerably worse and more difficult to clean up.
Right, and it's not just from incineration. I think it's just It's every way that we are degrading them. And it's a problem. We have to change the ingredients in plastic. And I don't think that we're going to get rid of microplastics anytime soon, if ever. So we have to really start pivoting on what we want going into our lungs, into our food, and what we want, into our mouths. It's a big deal.
Yeah. Could I just ask, do you feel that where we have these combinations of bioplastics and petroleum plastics that are being used in order to break them down faster, is that adding to the problem?
I don't think that it is. I mean, I think that that's a huge step forward. I actually applaud people for doing that, and it's a brilliant idea. And I think a lot of that has to do with the durability of the product. But at least we're sustainably minded. We're stepping forward, and we're trying to decompose these plastics faster. But it's one step when we need to be taking 10.
Yeah, we just use such vast scale of plastic around the globe that I suppose
Oh yeah,
it's enormous.
it's
Yeah.
unbelievable. It's unbelievable.
So if we go back and imagined everything transforming from standard plastic, conventional plastic to bioplastic, is there a solution in there regarding the end of life and this waste situation?
Absolutely. So bioplastics offer a big solution. And no, not all bioplastics are created the same, nor are they equal. I mean, many bioplastics begin to break down in 5 years under the right conditions. Others could last much longer, some much shorter, which is really fantastic news because when we start talking about shelf lives, we're not going to want the same plastics with the same type of barriers. For instance, some plastics we want a microbial barrier on that lasts longer. For instance, if we have electrical wires that are wrapped, we're going to want that go underground. We're going to want higher microbial level barriers, blockers to stop that from decomposing too fast, right? But if we have them on single use, we're going to want those levels to be lower. So, uh, I mean, it's fantastic news. But environmental factors they play a huge role in that time frame, just like the decomposition of all things. So, how they're being handled, are they virgin plastics or are they mixed? Are they starch based or something else? Are there additives and what do they consist of? Are they being thrown out of a car window and left, which they absolutely will be. That's a given. Or are there places where receptacles and facilities exist? All of these factors play a major role in how we move forward. It's also really important to note that just because good bioplastics are being formulated doesn't mean we won't run into other problems down the road based on their ingredients, meaning that if we want a dominant, dependable supply chain for a massive bioplastic market, we're going to need to grow ingredients in the fastest, most sustainable way possible. If we design to fix only one major problem, no matter how admirable, honorable, and necessary that problem is to solve, like making deep cuts into plastic pollution, but run into the same issues, corn for ethanol farmers are running into, we're going to create very expensive issues down the road. It's all connected. Since the bioplastic market is fledgling in comparison to traditional plastics, it's imperative that we as makers, as manufacturers, as consumers decide to get on the same page, meaning we will need to decide if additives that aren't 100% biodegradable are allowed or not. We're going to need to strengthen the BPI grade system from Food and Agricultural Oversight Departments that set standards for products who claim to be 100% BPI, just like they do with GMO free or organic certified and apply it to front end and back end bioplastics.
Yeah, it sounds like there's a lot of variation. So that labeling, that certification, that's definitely that makes a lot of sense. Regarding recycling, it's obviously a problem in regards to facility, but is it possible to directly recycle bioplastics?
You know, that's a really great question, and conversely, another big challenge and another debate that's going around right now. Can we recycle bioplastic? The ultimate answer is a resounding yes. The three largest groups of bioplastics are PLA, PBS, and PHS, or PHAs. Starch-based are usually PBS and PHA strains. By consensus, appear to be the largest group, specifically cornstarch, though source is not. The beautiful thing about all starch is that it breaks down to three basic ingredients, glucose and water being dominant. Glucose is a fantastic micromagnet, and it's been shown to, when it's been put into like cherry blossom soil, it makes soil. It creates the soil basically has a respiration rate that's larger and faster. So it makes soil breathe faster, which is wonderful. So it has a fantastic microbial magnet and water. Well, water, of course, is fantastic for almost everything. People actually add sugar to their compost piles to inhibit faster bacterial growth to quicken decay. And though it's not recommended for smaller composting gardens that don't have appropriate containers to house their compost due to pests and their love of sugar, larger facilities could benefit from glucose absorption. Even better, when composting microorganisms, CO2 is sequestered, compost soil mulch is made, and it can be used to grow more plants, making more, amongst various things, bioplastic. We have two major problems right now in bioplastic recycling that have nothing to do with specific bioplastics at all. The first is supply. The second is facilities. The plastics market is expected to grow to 1.75 trillion by 2025. The bioplastic market is only bringing in 6 billion of that market share. It has huge potential and plenty of space to grow, but to truly take advantage of a closed loop system and benefit from all it has to offer, there must be facilities capable of handling the growth. I without a doubt believe we can set up proper facilities and equipment to separate bioplastics from the rest. Within the same buildings where recycling and waste management systems already exist. Will bioplastics involve a standard where every company must add a certain ingredient that can be detected by weight, density, or likes? Will involve specific, inks that light or wave sensors can detect, or belts capable of detecting density and weight specific to these plastics? Maybe even micro pools where bioplastics will float or sink, as opposed to the other plastics and waste at the waste management level. I mean, what plastic will be composted and will be considered, usable quality? They can go back into raw material. What will that ingredient be? Will it be sufficient for all bioplastics? These are all, really big questions. Does that mean we're going to stop producing? No. We need bioplastics, and not just for the environment, but the livelihood and continued revenues farmers, specifically corn farmers, add to the economy. Right now in Washington, D.C., they're busy coming up with really incredibly good policies in terms of creating baseline living wages for farmers, which, in my opinion, is way long overdue. But at least it's on the table and getting strong support. But with the rise of electric cars, we won't need the same amount of ethanol we're currently producing, which is made from corn. The market is going to plummet to half of what we use, if not more. We need to begin phasing a pivot, and we got to do it soon. So bioplastics offer a major opportunity to do that, just that. And starch-based plastics not made from corn, which are drought and climate resistant, offer even bigger opportunities that will allow overplanted lands to heal, production to continue, no matter what climate change throws at us. If you invert those props, we gain space, which is tough to do with corn and sugarcane, but not with the most resilient starches. Couple that with a closed system composting facility nearby where nutrient-rich soil and mulch can be made and used. I mean, really, do I need to say more?
Yeah, it really is about this loop, isn't it? In terms of, we can't just from the material point of view, we can have a closed loop. That's straightforward from what you're saying. That's certainly possible. From a society point of view, that then has to have that supply, that facility, everything in place to ensure everything keeps circling round. But a question that comes to mind when you talk about the vast scale of this, the potential of the industry, we're talking about farming plastics now to grow them out of the ground instead of digging and using oil and petroleum. So it's going to put additional demand on land space if we was to make this shift. Already we're talking about, food shortages, or do we have enough space for food and the other resources that we need? So can you see that there's going to be a balance that we need to find, or is it possible that we can fit these in alongside?
When it comes to land, frankly, Source believes this industry should be the dominant, not the side hustle, since what Source is made from at least can also create food, fiber, glues, paper, pharmaceuticals, skin cream, biofuel. I mean, it's really incredible. Plants that aren't regulated like cannabis is, and could be a major catalyst and asset in how we will balance food, climate, economic land, the economy, land, and resource insecurity. So let's talk about land space, which is only a fragment of the issues associated with the land. Not only are we facing space issues with concern to population increase, but we're also facing issues with degrading farmland due to soil erosion, poor soil conditions due to overplanting of the same crops in nitrogen-starved soil, and land that has no reprieve to replenish its nutrients. To meet food insecurity and land use issues, the promise of vertical farms have come into play. We need them, but they come with a myriad of problems. We have over 30 hectares of space being allocated to vertical farms globally, and only Japan is making a positive return on investment. And that's not a dig at all on effort, innovation, or the amazing teams running these farms. It's simply the reality. That doesn't mean they're a bad idea. Not only are they a good idea, they are essential in the long run. But to make them efficient, further profitable, we've got to find ways to lower their energy use while creating enough profit to afford higher levels of automation. Vertical farming creates massive carbon emissions due to the high LED and energy use, which then drives produce prices much higher than traditionally grown produce. But what if we grew plants that need less water, that need less light, less nutrient-dependent soil to make plastic as well? Like a side-by-side project, one hand washing the other, so to speak, to create a positive ROI with an abundant and needed product that turns into dollars and doesn't really have a massive shelf life like produce does. and in return for knowledge and the expertise of vertical farmers to balance out their bottom lines and energy consumption. Source not only believes this is possible, but plausible, and if not side by side, then on its own. It would make the most sense to partner, but for the knowledge base and facility space. But if not, Source believes the ingredients it uses can be grown in the same way vertically or not, though vertically is ideal.
So in terms of vertical farms, we're talking about indoor growing at this point. The idea being that we're going upwards and making it possible to produce or to have more space than just the footprint that the farm is stood on. So this is indoor growing, and that's why it's so intensive regarding the light and the water. We're not really growing it in the soil. Is that right?
Well, that is what is happening with vertical farms now. But the really brilliant thing about these ingredients that Source uses is that you don't have to have them indoors because they are climate resilient. They are less water intensive. They can handle lumen saturation, but still at the same time don't need a lot of lumen saturation, which potentially means that we could grow them almost anywhere in the world. And the only reason that they needed to really be vertical is because of land space, and putting them in the middle of a place where the soil and the land has been overplanted, or it's not they could be grown in places where there isn't a lot of soil. They can be grown in places where there isn't water readily available, but they do not have to be inside.
So this is the versatility of the very specific crops that you're looking to integrate into the plastics themselves instead of sort of food and all the different things that we might want to grow. There's a very specific condition that these plants can manage in that other plants can't, and therefore
correct. And because produce you have to, it takes a very delicate ecosystem, but these could be something that did not so much.
So you foresee it being able to be done on a large scale, and whether vertical or not, vertical's better because there's just more density in terms of land space.
Correct.
Yeah, fantastic. And we're touching here on your own specific plastics now. These are crops that you have started to use in your own research and your own development. So with your own work, this is something specific to you, just to let the audience know. We're now talking about your own product, but could you tell us the story behind it?
Absolutely. And so the ingredients are from these crops that are already being grown all throughout the world. And so a lot of the research comes from research that's been done for centuries and centuries. It's just that when you look at what's been done and then what the potential that could be, it's not it's not rocket science. They go together well. But yeah, I would love to. So I spent a few years picking up hundreds, if not, it was just hundreds and hundreds of pounds of recyclable plastic by hand. I didn't do it for money, not for anything but the fact that I had traveled all over the US, and no matter where I went, I found discarded plastic woven into the natural landscape of almost every environment that I was in. It didn't matter whether I was camping on the side of an ocean cliff or in the mountains next to massive redwoods. It didn't matter if I was in the desert with packs of coyotes running past my feet, in cities with recycling programs, or small country towns. All the landscapes and people changed, but one thing always remained the same, and that was plastic pollution. I didn't mean to, but I ended up garnering some attention for it and tried to run with it, thinking it would bring more attention to the problem, that maybe people would wake up. And that didn't happen at all. It actually backfired. People took it as, a his thing, a spectacle, something to watch, not do themselves. I'll tell you what, that just really, really started to make me very angry, very, very spitfire angry. I was watching animals get sick. I was watching plastic wash up on the shores during some of the most beautiful sunsets I've ever seen. I was watching businesses send hundreds of pounds of plastics and trash straight into the garbage. Thank you, yoga, namaste. MFs was often uttered from my lips. And in hindsight, I wouldn't say I'm happy that's what happened, but I can say it needed to happen. I would get so mad that it made me dig deeper. And at first, I thought it was a people problem. Then I thought it was a municipality problem, lack of oversight and education. And it is, and it isn't. It made me research. It made me find ways to deal with all this plastic, how to reuse it, how to create programs that made cities money, or at least, break even on creating recycling programs that worked instead of it costing money to recycle. I ended up creating a proposal to create 3D print filament out of recycled plastic before anyone in the US was doing it. And I was graced in that time with meeting a few amazing people, some people from Greenworks on the East Coast, but they were just as angry, and they had progressed way further along in this game. They created 501c3s, and they got nowhere with them. I mean, people getting shut down with great ideas, strong break-even proposals because of politics. Then, when I was on the East Coast, Baltimore's new $10 million recycling facility shut down because of the issues like bowling balls in the recycling stream, separation overwhelm, and then smaller recycling centers began shutting down all over the country, which is still happening. So, it came to, what's the point? What's the point in creating innovative ways of reusing this plastic if it was still going to end up in the oceans? If communities, municipalities, and the government weren't going to take hard stands and create real change? I'm against making anything that could harm our planet, even if reuse is better than single use. And if I couldn't trust that the products made from the filament I wanted to create would be recycled, I had to find another way, like some way, any way. It was exhausting. And I was exhausted, but the angst is a mighty, mighty beast. Then it occurred to me, if I couldn't change behavior, and even if I could, and I couldn't change politics, then what if I could take the ball completely out of both courts? So what if behavior didn't matter? What if plastics, worst case scenarios, still ended up in oceans and landfills? What if only money talked? Could there be an additive that would degrade petroleum-based plastic? Then the grim and very toxic reality of microplastics hit the scene. It was just bullets. Japan, by the way, has discovered a bacteria that eats PP plastics, but it's a long way off from being commercially available. And it's still a Band-Aid. I mean, it's Marvel Studios with aloe kind of Band-Aid, but it's still a Band-Aid. Japan's doing a great job. Then I found the promise of bioplastics, and I was totally reignited. I mean, this was years. And this had major potential, a closed loop, circular economy potential. I mean, space potential. And when I'm talking space, I mean, Mars potential. But it has varying problems. So, many bioplastics lasted too long or needed other mixed additives that kept them from being brittle or hard to work with, which brings us back to the same sorting issues, the same pollution issues, the same Band-Aid thinking. So I set out to create a more durable bioplastic that could break down faster while being more durable through natural, fast-growing additives. And it worked. As the plastic showed visual and haptic differences between what was already being made and what I was making, the opportunities into how to solve so many other global issues well beyond plastic pollution, even a few for space, began unfolding. And that's exactly what Source was designed to do. Do we have a long way to go? You bet. But this is the way.
Yeah, it sounds fantastic. So you're talking about a real solution, a plastic that does the job we need it to do, and then disappears. It's gone. It's not providing this year and year and year on stack of problems. So yeah, beautiful.
And that's the thing. And if it does go years and years and years, if it breaks down into microplastics that are non-toxic, I don't think that we're going to get rid completely of the eyesores of plastics. Our consumerism is just so high that I just don't think that that's going to happen. But if we know that they're breaking down into microplastics that aren't going to make us sick, that aren't going to make our environment sick, that aren't going to hurt the oceans, I think that's a massive win.
Yeah, absolutely. Because we've got two enormous forces at play. We have got consumerism. We have got that ever-growing trend of more and more use. And I don't think we're just going to turn around and sort of knock that on its head and say, no, we're going backwards. We're not going to have all of these products. But we've also, as you've just expressed, got this growing sense of passion
almost to the point of anger at seeing the world start to degrade. And actually, that's becoming more apparent. And the more apparent that that becomes, the more people like yourself jump to this passion, and it becomes frustrating. What you've described is sheer frustration, really, along the way. But we have to combine these two. We have to combine the passion to create the change, to look after the world that we're living in, but also this desire to live lives in the way that we're accustomed to, and this consumerism and this product use. And I think ultimately what this combines into is it's the producers, the manufacturers, the facilities, so all of the companies that are involved. And in a lot of ways, they're having more pressure put on them. There's a lot of pressure put on companies these days to be more sustainable, to be more transparent, and to be more aware. But I think we're also looking at a situation where their choices are still going to be about the bottom line. They're still going to be about money, and they're still going to be about what is a product that's provided that meets the needs that they're looking for, the application. So do bioplastics provide a solution to the company regarding costs and these other sort of priorities?
Absolutely. And first, let me stress the importance of the times we're living in. I've spoken to several manufacturers, people both at the top of these companies and those that work in the ranks. And from all I have listened to and researched on, inclusive of all the amazing research Fictive performed for their 2021 manufacturing report, I believe many manufacturers have a true and real intention when it comes to sustainability within manufacturing. That may have not been true in the past. They may have not been as aware, or maybe there were. I don't want to speculate there, but what I do know is that, it's not, at this point at least, it's not simply because of pressure. They want sustainable ways of making great products. I mean that's business, and they want to be able to do it, at a great cost, which is good business. But it's in their hearts. But without enough supply, it's a rock and a hard place situation. Yes, cost, of course, is one of the forefront issues in any business. The second biggest issue is the reliability and dependability of supply chains and vendors. So many manufacturers have admitted, and this is recently, this is in 2021, that their vetting for vendors needs a huge overhaul. But it's they who brought that to the table and are currently building new standards into their vendor vetting. That's a huge move. And they are the ones who brought those issues forward internally within their companies and have set out to solve them. Now, I'm not saying that they don't have a lot of people breathing down their necks about the lack of sustainability mindedness in the past. But for those that I have spoken to one-on-one, these are real people who really do care about these issues. So most manufacturers have 3 years worth of bulk inventory on hand. So if you go to a manufacturer and you want to make a plastic part that they've been making, they have a plastic supply worth bulk inventory on hand for 3 years. It's how they forecast their projections, and they base their sales on scale. Can they make good costs? The thing about bioplastics is that, like any kind of supply and demand, when you have enough supply, it drives down demand, and that drives down costs. So that's why we go back to saying we need a lot more companies making bioplastic. We need waste management facilities that can handle these bioplastics. But yes, since you're not taking fossil fuels out of the earth, when you get into production, when you get into manufacturing, when you get into the actual process of making bioplastics, it actually costs a lot less than it does synthetic plastics. But because there's so many people making synthetic plastics as opposed to bioplastics, they're about the same cost at this point.
Okay, so that's very promising. So at the current state, the same cost, but if the scale increased, which it has potential to do so, there would be potential to drive price below what the current standards are.
Absolutely, because a lot of that has to do with port fees. A lot of that has to do with having, shipment fees, things like that. But depending on where you are and where these manufacturers are, for instance, a lot of manufacturers are talking about reshoring in the U.S. I don't know what's happening in the U.K., but what they were doing is they were buying their bulk product from overseas and then shipping it over. So, that raises greenhouse gases because of the ships. That raises port fees, that raises, all these different fees, cargo fees, all these things that actually are built into these plastic prices. But because manufacturers have become so much more sustainability minded in 2021, they're actually looking for ways to reshore, at least in the US, but they need raw material to do that. And bioplastics offers a really good opportunity since they usually have a 3-year supply on hand.
Yeah, so it's given them that transition time. It's
Right.
yeah, huge potential. It's like the vision's there, and the solution is sort of within that, and it would just to sort of, like you said earlier, it's fledgling, it's right at the beginning, but it's certainly showing enormous promise.
Absolutely.
Yeah.
It's exciting.
And there's something here that we've touched on already, but something that I'd like to just sort of mention a little bit more and get a few more details. Bioplastics break down. This is the benefit. We can biodegrade them. But compared to me putting a plant in the composter and that breaking down and providing nutrients into the soil, there's some differences due to the processing that's been taking place or the additives that have gone in there. So are we looking at a problem with toxins potentially within the decomposed material? Or is this again dependent upon the material that we start with?
Yeah, I can't speak for other bioplastics companies. I'd love to say no. There are no problems, no toxins, but I simply don't know. I can only speak on Source Bioplastic and its mission to formulate a completely non-toxic, durable bioplastic without the addition of hardening agents that aren't natural and not sustainable, which it has done from completely natural sources. The fire retardant it will use will be non-toxic, and as we vertically scale, there is no doubt that there will be hurdles in terms of creating a natural 3D print filament that is capable of being used in large-scale additive manufacturing. But that in no way means we won't accomplish our goal. Source is already well aware of what it must find and do to hit that goal. What I can say about starch and sugarcane-based bioplastics without additives, they do break down into carbohydrates. So you have nutrients there. If fungi or the likes are used in decay and composting processes, it will add even more nutrients.
So yeah, ultimately we are throwing away a plant, or we have something very close to that in the ambition that you've set out for.
Correct. There are other ingredients in bioplastic, but none of them. There are a way to source those ingredients naturally as opposed to synthetically, and without taking from the earth, but actually adding to it.
And you mentioned things here to suggest there's a lot more complexity than what somebody like a layman like myself would realize. Like you mentioned 3D filaments or 3D printing filaments. So this is all the reality, the practicalities of the day-to-day manufacture that people aren't gonna have the scope necessarily to be aware of the hurdles that you're facing. But the fact that this work is being done, I think, is music to many people's ears, that we are heading in this direction.
Right, and that's exactly it. Is that people do need to understand that large scale additive manufacturing where massive 3D printers are going to be developed, and they are going to be very useful, and that is where you can't just develop more band-aid solutions for what's now. You have to look down what we're going to be using in 50 years, and that could change significantly too. But we have to hit these goals by 2030 from the UN, and it's important that we understand where the world is going in manufacturing, and it's important for makers, consumers, and raw material growers to understand that we have to be ready for them when they're ready, because otherwise we're just going to have the same problem. It's the future of our world, and it's one of the biggest products we use, and it's the one thing that can get us away from a whole lot of fossil fuels and a whole lot of problems with climate change.
Yeah, it is a huge. I mean, you've mentioned numbers here. It sounds too big for me to even imagine the scale of how much plastic we use, but it does sound like something that it can't go under the radar. It is enormous potential for improvements.
Correct.
And we're working with nature regarding these. We're touching on this ability and nature's natural process to break down. And this brings me to the thoughts I've come across stories where fungus is being used to break down oil spills, to clean up oil spills. It has such incredible compounds or ability within nature. We have such a manner. I don't think we've even scratched the surface regarding the microorganisms and the fungi and these kind of things. So if there's such promise there in terms of remediation with fungi, is there also potential for them to be explored further in the act of breaking down bioplastics?
Oh, absolutely. I think so. Absolutely. And it's interesting about the oil spills because I think they used horsehair with that and sucked that up. I learned that from Berkeley recently, which just blew my mind. The fact that we can use these, these different. I think they said something like there's so many different strains. We think about our mushrooms that are going into our salads, and but there are so many strains of these, and the fact that you can make they're so complex that you can make building blocks, true construction bricks out of something so soft in your mind like a mushroom. It blows my mind. But yeah, so fungi have shown really great promise. I mean, remarkable, in fact. It should be considered a viable option. But I don't believe the issue is in finding dynamic, potent sources of what can be used to quicken compost rate decay. I mean, air is full of spores. Simply moving compost around or forcing air through it creates heat pockets at the center that aid in faster decay. Creating microbes is easy. It's that the science isn't being exploited. I mean, if you're lucky enough to order a beverage from a place that uses compostable plastic cups, you'll usually find two sets of text. And I don't know if you've ever seen one of those, but I'm sure everyone has at least had one compostable cup so far. And the interesting thing about them is that one of those sets of text will read certified BPI, and the second will read commercially compostable only. Facilities may not exist in your area. I can't be the only one saying to myself, well, what the hell? That's no solution at all. I mean, does that mean they only degrade in a facility? And that's the catch, right? So when composting facilities do exist, what I've learned is that in these facilities, because there is such a mass amount of compostables upon arrival, it's put into large staging bays. So it's set up basically, 1 through 5. It's sifted, and as decay begins to take place, it's moved to the next phase bay until you eventually arrive at a soil mixture in the last bay. It's processed. So heavy reliability on Mother Nature and 140 degrees and above temps in the middle of these piles creates the decay. So it's hard to say, we can do better when simply having a composting facility is a luxury. Like any major challenge we must overcome, just because a solid solution exists does not mean the world is ready for it. We have to catch up, but why? I mean, maybe it's education may be the problem, profit and loss, maybe. I don't have an answer for that. Maybe it's the soil doesn't create enough revenue to make deeper municipal investments, or maybe it's that integrating recycling programs were supposed to be the answer. Yet when many plants across the country shut down due to poor recycling practices, obviously it would make leaders second guess making even bigger investments into problems that seem too big to remedy, at an astronomical cost. But bio-based plastics could create revenue to offset the cost of these facilities.
Yeah, that makes sense. When we come to a cup and it says this is compostable, but only in commercial facilities, is this dependent upon the material that it's made out of?
I can't find an answer on that, and I'm kind of blown away with that too. I cannot find an answer on that, and I assume that's because of the NDAs and all these other things. I can't find an answer on that. But it seems like it's like the right direction, but almost.
Yeah, just a little bit more clarity.
Just a little bit more. But what do you mean you can only do it in a facility? And that's why I don't know. I don't have an answer for that. But I don't want that to be on my product, and I hope that it never is.
Yes, yeah, absolutely. I think the ambition that it doesn't require something that's not available, that makes perfect sense. Yeah, let's not have that restriction there. And let's just sort of flip this the other way around and look at the absolute worst case scenario. Let's say we replace conventional plastics with bioplastics, but the bioplastics then end up at the bottom of the ocean. They end up in the verges. They end up where they not sort of ideally placed. Are they going to break down?
Source will, yes. I mean, I have what the issue is that I'm having right now is keeping it around longer. But I also haven't industrial pressed my plastic yet, so that's a whole new that's going to be a whole new challenge, and it's going to be really exciting to see what happens with that. So I can't speak for other bioplastics. I think that the point is that most of these bioplastics are starch-based, so yes, they will break down. When that will happen, I mean, that's the point of them. You know, somebody throws it out their car window. Eventually, these are going to break down, and not within 450 years. But still, you know, there's a lot of questions surrounding that only compostable in a facility, and you know, I'm learning as we go as well on what that exactly means. I can't answer it.
Yeah, I'd kind of assumed that there was a durability to that particular plastic, but it sounds like it's more complicated than that. Maybe
Yeah,
less
and,
transparent.
yeah, it's interesting. You know, I hope that never survives on any of my stuff.
Yeah.
I, I'm a little shocked and odd. You know, I just hope that we're not going down. You know, it's like if you have this really great idea and this really great product, I just want to know a little bit more about what that means because I have the same question.
Yeah. Yeah. Interesting. So, I mean, we're heading in the right direction. We've got the potential here. We've got the ideas and the right minds on the job. But we are talking about a huge scale shift that
Oh
is
yeah,
so many steps along the way. So it's going to be an interesting journey to see it unfold, I think,
right.
to
Hey,
see
very
where things
exciting.
take us. But we are on a sort of more, I suppose, breaking it down to its simplicity. We're talking about a material with bioplastics that's renewable in the resource, whereas the conventional plastics we're depleting or we are taking from the earth and we're not putting back in. So there's a huge benefit to that. But what I wondered if we took that one step further and we said the bioplastics are coming from plant material, we're growing this, we're potentially growing it regeneratively and building soil in the process, do you think that there could be a positive impact on the environment from the production of bioplastics?
The short answer to that is yes, on a big win for the environment in terms of sequestering carbon. But you know, it's dependent on product and situation. I mean, there because we have at least what I'm finding, you know, bioplastics that I can't find answers to on, you know, do how long do they degrade? I don't want to give a resounding yes for all bioplastics. What I can say though is that yes, on a big win for the environment in terms of sequestering carbon. But again, it's totally dependent on the product and situation. Making synthetic polymers from fossil fuels creates really heavy carbon emissions from how ingredients are sourced to how they are transported, formulated, manufactured. And the oversight, you know, it's all carbon heavy. It's much higher than bioplastic production. So plants have a really brilliant CO2 source slash sink dynamic. So plants become a source of CO2 when they're growing with optimum nutrients like lumen saturation, nitrogen rich soil, and plenty of water. But when you starve a plant from basic nutrients, it switches to pulling in more CO2 from the environment into its roots to create growth. So now imagine a starch source that can grow well under starved conditions, natural CO2 sink systems. This is where source bioplastic is different. The plants use their natural CO2 sinks. Then to take them into a hypothetical step further and grow these plants in vertical farms that are heavy carbon emission contributors that have the potential to offset those emissions. The other brilliant thing is that these plants not only make polymers, but food, fiber, biofuel, glues. So other starch-based bioplastics would be harder to grow inverted because of the vertical space needed for the plant to mature, like corn and sugarcane would need. So take it further to composting these plastics, and you sequester even more carbon. So growing plants is additive to the earth by nature, not a subtractive approach like using petroleum for traditional plastics. And since many communities all over the world burn all their trash, no matter what it is, bioplastic offers an alternative that can go into creating new soil and mulch, which also lowers greenhouse gases. So across the board, you're going to see a subtraction in carbon emissions.
Yeah. Yeah. So
Now, go ahead.
it's just sort of we're multiplying the benefits every step that we take towards increasing the use of bioplastics.
Right. Absolutely. I mean, and that's the thing is if these manufacturers are going to reshore their operations, if we're able to, let's say we're able to plant, closer to these manufacturers, like, so one of Source's bioplastics ingredients as an unprocessed raw material has a harvest shelf life of years. I mean, they can stay in the soil for years and continue to grow. So if manufacturers' material supply is 3 years deep, that could set up a really interesting solution potential as to how a dependable supply and demand chain can be met. So the pieces really all begin to align into this incredible problem/solution puzzle, and the image from all sides is really quite remarkable. But take this into consideration. If we're able to plant our materials, as opposed to having to go to certain spaces to be able to pull petroleum and have it transported, then made into plastic, then made into, and then sent to the manufacturer to be made into products. If we're able to plant them and we're able to plant almost anywhere in the world, you can cut the distance between the manufacturers and the plastics that are being made. It's really stepped very, very well in comparison to what the traditional systems are now.
Yeah, it's bringing a localization potential that you just could never get with a resource that's specifically located in the ground somewhere. It
brings economies to places that never would have them before.
Yes. Yeah, it's actually very exciting because the more that we sort of see this more in the direction of change, we can get quite creative. Like you've just mentioned, essentially, I suppose what you're saying is your stock remains in the ground until you need it.
But for the most part, yes.
Yeah.
And before processing, yes. And if that's true, in the sense that if it can be planted as opposed to, think about how many small scale farmers there are in the world that could be farming for plastics that aren't capable of farming produce, aren't capable of farming, plants that are a lot more sensitive to climate change, or plants that are a lot more sensitive to having copious amounts of water. But if you're farming for plastics instead, and not having to worry about feeding people with it, it opens up a lot of possibilities, a lot of freedom in farming. And there's people all over the world that have to worry about their crops, but this gives them another opportunity to become, smaller scale localized farmers into plastics.
And I think that resilience, that versatility, that ability for a crop to be grown, maybe it's going to be used for bioplastics, maybe it's for food, maybe it's, the fact that it can be multi-purpose, that expands the options. And I think
Infinitely. Right.
It allows that creativity to sort of come into play and things to be a little more open to solutions to be found. So it is definitely very exciting. And I think also you might be scratching on a lot of problems with fresh produce, where you've got locations that are quite isolated from a distribution that can get them to market very quickly.
That's right. And, the thing is if you can create instead a plastics economy and a farming culture around that, that could create the money to create those pipelines for better distribution of produce that we all, that everybody needs and absolutely should have. And, if you can't build it one way, you can always create, the versatility of money to create those systems. And that takes a legitimate cash product, and that would be plastics.
With regards to the the plastics at Source, is there a number of different crops that will be involved?
I don't know about the fire retardant yet. We're not there yet. There will be some, but all the crops that would be involved, they have the potential to create so many things that it's just honestly, my mind is kind of blown.
Yeah,
You know,
yeah, the potential
it's kind
is.
of right, and it's going to take a lot of hands on deck. But yeah, plastics is where you start, because it's not simple, but it is what is going to be needed most, because everything else is kind of secondhand when it comes to skin creams and things like that. Anything else that you can make, and you need a lot bigger lab equipment. You need bigger chemical teams. You need all the for these other products. But for plastics, you they can be made fairly easily.
Is the manufacturing quite easy then? Is it input heavy to make a bioplastic?
I don't think it's input heavy, but if you want to do mass scale, and if we're talking about really being graded on a BPI level, there's a once testing happens, then replication can happen. Once replication can happen, then it's really about just distribution, and finding your customer. But yeah, I mean, it's not very hard. And then of course, you use the ingredients from the plants that are being grown all over the world already, and then you take out those people that are making them, and you start to make your own to obviously bring down your own business costs. But it's not as hard as making biofuel.
Okay, yeah. And I imagine that something we haven't touched on is the comparison of like a plastics factory, sort of on a conventional sense. We're going to have to locate that somewhere where it's out of domestic constraints, because there's a lot of fumes and a lot of nasty stuff going on there. But it sounds more like if we're making bioplastics, this is a little less noxious.
Yeah, it absolutely should be. And you have large scale dryers, and you have all these things, but ultimately, if you're not dealing with chemicals, it definitely does make things less noxious.
A Source at the moment, is your ambition to focus on bioplastics for the use of a specific, say for packaging, for something you mentioned for the ultimate thing that we need the most priority on is single-use products. Is that where you're focusing?
Focusing on pellets, films and things are interesting. There's a lot of people working with films, but I think pellet form is probably going to be our first and biggest step, and then moving probably more into filament, only because it's market positioning. But films are amazing, and it's if it can be made, I have no idea yet if it can be made into a film. We just simply do not have the equipment to do that, and it's just not the focus. And the thing with pellets is that anybody can take them, they can buy them, and they can hopefully do what they want with them. We're just not at that step yet. We are. This company was started in 2020, and we have a long, long way to go.
Yeah, no, it sounds like an exciting way ahead as well. And
Yeah, long, long way to go.
you've got that stage where it's bursting with so much to get going. You
It's
don't
so
know
much
where
potential, and so many pitfalls, so many pitfalls to go.
Yeah, so many adventures. Keep it
Absolutely.
positive. Yeah, absolutely. So, no, it's been a very fascinating discussion. I've learned a lot. I think it's an industry that leaves an awful lot of questions, and you've answered so many of them for me. So I'm really, really grateful for that. And
Absolutely. Thank you for your time, Ellen. I really enjoyed this as well.
no, thank you. It's been like I say, wonderful to learn not just about the plastics, but also about what you're doing, which sounds like it has the right mindset behind it. If I was making a bioplastics firm, I would certainly be looking for some of the ambitions that you're taking on in terms of the no toxins, keeping it all natural, degrading quickly. It's very exciting stuff, very interesting stuff. And what's the next step for you?
Thank you so much, truly. So the next steps for Source, proving all these bold claims I made. I mean, talk is cheap. Third-party testing is next. Results matter, but I'm confident. Then likely equity funding.
I wish you all the luck in everything going forward. It sounds exciting.
Helen, thanks so much.
And thank you for listening to this episode of We Are Carbon. Next time, we'll be joined by Lara Hussein for a wonderfully inspirational talk on the Waste Lab, a business that is demonstrating the power in the simple with their collection and composting initiative in Dubai. You can keep up to date with everything from We Are Carbon by subscribing on the website or following along on Instagram. Search for wearecarbon.earth. And let's keep figuring this all out together.